This is Pre-Calculus, Section 3.5, Higher Degree Polynomial Functions and Their Graphs. The beginning of this lesson is review of things we covered in college algebra. You should remember that if you have a function of degree 3, then we're talking about something like x cubed. The graphs generally look like one of these. It can cross the axis 3 times, like these two graphs right here, or just cross the axis 1 time. Those are your cubic functions, degree 3. Your quartic functions, which is degree 4, y equals x to the fourth plus or minus, etc., will either do these two things down here, where it's like a w or an m crossing the x-axis 4 times, or it's going to resemble more like a parabola. In addition to knowing what these graphs look like, you should remember something called end behavior, meaning what happens to these graphs far to the left and far to the right. And we covered that in this chart. The two major things you have to remember for determining end behavior is the degree of the polynomial and if the lead coefficient is positive or negative. Now, the word lead can be misleading in terms of it's not always the number that's in front. Be sure that your polynomial is written in descending order of exponents before you determine lead coefficient. So the lead coefficient is actually the coefficient that is in front of the variable that has the highest power. So in this case, this was x to the fifth. That was an odd degree. It has a negative lead coefficient, so we know it rise, comma, fall. Now, what does that mean? That means it rises to the left and falls to the right. So that's what we did in college algebra. We just used those words. What you're going to see now in pre-calculus will be a little diagram showing you that it is rising to the left, and then little dots in between here because we're not sure if it's one of those that cross 3 times or just once, but then fall to the right. So there'll be little dotted in between there. This here has x to the fourth, so it is an even degree. So we're looking at this part of the chart. It has a positive lead coefficient, so it will rise, meaning rise to the left, rise to the right. So the little diagram looks like this. It rises to the left with little dots in between because we're not sure if it's going to be the parabola look or if it's going to be the M or the W kind of look. So that's what you will pick out off of MathLab. We'll end up using this end behavior to pick out some multiple choice graphs just based on the end behavior. Now, extreme points, meaning max and min, we talked about in college algebra, but we have a new word here. Extrema is just the general name for max and min. You know, a local maximum point is a peak and a local minimum point is a valley, and they're also called turning points. Now, terminology is important here. A local maximum point is an ordered pair. So if you are asked for the local maximum point, you need to give an answer as something, comma, something in parentheses. However, you could be asked what is the local maximum or what is the local minimum, and then they're just looking for the y value. They're looking for one number, which happens to be the y value. We also can have an absolute maximum, which would be the absolute highest point on the graph, or an absolute minimum, which is the absolute lowest point on the graph. We do not have to have an absolute max or an absolute min for a graph. So take a look at these two graphs over here. What is the absolute max for figure A? Figure A is this one right here. Absolute max would be what is the absolute highest point on the graph is this point right here. So the absolute maximum point is x2, y2. But what you're asked for is what is the absolute max, means we're just looking for the y value at that point. So it's y sub 2. Does figure A have an absolute minimum? Well, it does have a local minimum. That's a little valley right there. But that is not the absolute minimum because this graph continues forever all the way on down to negative infinity. So it does not have an absolute minimum. Does figure B, which is this figure over here, have an absolute max? It does have a local max right there, but is that the absolute highest point in the graph? And the answer is no, because that continues beyond that height forever and ever to infinity. So it does not have an absolute max. Does it have an absolute min? It does have a local min, but is that the lowest point of the graph? No, because this continues beyond that all the way down to negative infinity. So hopefully you've picked up the idea that when you've got infinity or negative infinity involved, you will not have an absolute min or absolute max. Now this next part is going to be complicated for me to try to explain to you because I cannot show you a screen clipping of the actual graphing calculator. So what I suggest you do is that you do one step at a time, stop the video, look at your calculator before you go to the next step. So here's our steps. Number one, get this entered in your calculator as the function. Notice if you are in the standard window, which is -10 to 10, that your picture goes below, and we really do need to see this down here to figure out what the minimum is, so we need to play with the window. So I would suggest on the window that you keep your x min -10, your x max 10, your x scale 1, but let's go with the y minimum of -20. Keep the y max as 10, keep the y scale as 1, and then hit your graph and see if you can actually see the bottom of your parabola, and you can. So that's the first thing. Get it into the graph, get the window adjusted so that you can actually see where the minimum is. So we're right here. Press trace and move the cursor just to the left of that perceived minimum. So I use my right arrow and keep bouncing down till I'm just getting really, really close to that minimum. So my cursor has stopped about right here. What my calculator says underneath there says x equals 3.4-ish, y equals -12.6-ish. Your number might be a little different if you stopped a little further away or a little closer, but you need to be to the left of that minimum. Now hit second trace, and you have a bunch of options there. We need to choose number 3, which is minimum, because this is clearly a minimum point. So you can bounce down to minimum, and now your calculator says left bound ? 3.4 for y. I'm sorry, 3.4 for x and -12.6 for y. Well, that's not the minimum. That's my left bound. That's where I'm sitting right here as I'm approaching the minimum. So now hit enter. What your calculator says now is right bound. What we need to do is move the cursor just to the right of the max or min. In this case, it's a min. So move just to the right of the min. So now my cursor's sitting about right here. What my calculator says is 4.68 for x and -12.5 for y. Like I said before, your numbers could be a smidge off. But my left bound is right here, my right bound is right here, and my minimum is in between there somewhere. So where it has right bound ? The calculator is saying, are you good enough with that right bound? And we're going to hit enter because we are. The next thing that comes up says the word guess. So the calculator wants to know, are you ready for me to guess? And we are, so we hit enter. And it comes up and it says minimum x equals 4.0000, so I'm just going to go off to the hundredth place, and y of -13. That is the minimum point for this parabola. I know those steps are complicated, so you might want to rewind the video, go through each step at a time. We're also going to do max and min on this next problem coming up. So now we have a new function. Take a second, get this entered in your calculator. And notice when you hit graph using the last window we had, what you have is a picture that looks like this. You see this, and then you see this. You've got to see what's going on down underneath here. So you have to play around with your window, but I'll tell you what it is. Here's the window you should use. -5, 5, 1 for x, and -50, 50, 5 for y. And then your picture should look something like this. You can see you have a minimum, a local minimum here, another local minimum here, and what looks like a local maximum there. So we will go through those steps in just a minute, but first we'll determine the domain of an interval notation. Domain is, from left to right, and what this graph does is it takes off to the left, it takes off to the right. Therefore, your domain is just the infinity family, -infinity to infinity. Now let's work on this one over here first. So my steps are, number 1, hit trace. Use your cursor, use your left arrow to get your cursor over on this side, over here somewhere. My calculator says -2.23 for x, -41.3 for y, so that's about where I am there. Now hit second trace. Choose minimum, and it says left bound with a question mark. hit enter, because all you're doing is letting the calculator accept that value where your cursor was sitting. Now it wants to know what your right bound is. Use your right arrow to get over on the other side of that, which is about right there. Right bound question mark, hit enter. It says guess, hit enter. And what the calculator says for me is negative 1.89, actually 1.885, but we're rounding to hundreds place, negative 1.89, comma, negative 44.277, which is 28. Now that is not only a local minimum, it is also the absolute minimum. So remember that when we enter that at the end. Another minimum is this one over here. Now I always just like to clear everything out, so I hit second quit and then hit graph again so that I have a plain old graph and I'm ready to go through those steps again. So trace, get your cursor over just to the left of that point. So my cursor is sitting about right here right now. Now I'm going to hit second trace, hit minimum. Comes up, it says left bound. So in other words, are you happy with where you have placed your cursor? My left bound says x equals 0.319, y equals negative 30.8. Hit enter because I'm happy with that. Right bound question mark means I need to move my cursor over on the other side. So now this cursor is about there, which is x is 1.28, y is negative 29.5. So I have surrounded my minimum right there. Then I'm ready to hit enter for right bound. The next question that comes up is guess. Hit enter after that. And the calculator says 0.839, which rounds to 0.84, comma, y value negative 32.30. So this one right here is a local minimum. This one right here is a local minimum and an absolute minimum point. Now, same steps to do the maximum. So I will clear off. I'll hit second quit so that there's nothing on my graph. Hit graph again and start. So now I will hit trace, and I want to bring my cursor to be just to the left of that perceived maximum. So now my cursor is about right here. It's just to the left of that maximum. Hit second trace to come up and bring up maximum, not minimum. Choose maximum. And that is now my left bound. I hit enter. To get the right bound, I need to move my cursor over on the other side. Hit enter for right bound. Then it says guess, and then hit enter after the guess, and the calculator says negative 0.08, comma, negative 29.959, which would round to negative 29.96. I'm going to answer the range when I get to another screen. We can do the x-intercepts and the y-intercept on this screen. X-intercept is just where the curve crosses the x-axis, and you can see that from the graph that this one over here is negative 3, 0, and the one over on this side is 2, 0. Now I just eyeballed that looking at the graph. You can use your graphing calculator and double check that those really are your x-intercepts by looking at your table. So you hit second graph, which brings up table. Your x-intercepts have a y value of 0. Look in your table for where the y values are 0, and it happens at negative 3, and it happens at 2. Remember that the y-intercept is wherever x equals 0. So you could look at your table and look at the x value of 0 and see what the y value is. Or, arithmetic-wise, if you put 0 in for all of these x's, those all go away, and we just get negative 30. But that's a y value of negative 30. You do need to enter it as an ordered pair, so 0, negative 30. Though I need to point out that you were asked on part C, determine local max points. This is a local max, and tell if there is an absolute maximum point. And the answer is no, there is not an absolute maximum point. That is the local max, but it is not the largest because that graph takes off up and up. This screen has the same graph that we had on the other screen, but I have filled in all of those answers that we did here for the min, the max, the x, and the y-intercepts. So here in black, I've got my x-intercepts indicated. I have my minimum here in blue, a minimum here in blue, and we have this maximum here in red. I need to do the range. The range is low to high. So coming in from the bottom, my least y value is negative 44.28. My least y value is negative 44.28 with a bracket, and where those y values are going, all the way up to infinity with the curved parentheses. The reason I filled all these other numbers on here, it will be easier for us to name the increasing and the decreasing. We can see what is increasing, but it's nice to have the values right in front of us. Like this right here is an increasing interval. You can see clearly that that's increasing. Well, what's the x value right there? The x value right there is negative 1.89. And what is the x value where it stopped? Negative 0.08. Remember, for increasing and decreasing, we are giving our answers in open intervals, and that is why we get parentheses. That is not the only place our graph is increasing. Our graph is also increasing from there on up. So the x value there is 0.84, and where is it going? To infinity. Two major things to remember from increasing and decreasing. You are using parentheses because it's open intervals, and you are giving the x intervals. Always the x values for increasing and decreasing is over here. All of this is decreasing right on down to there. So the decreasing is from negative infinity to the x value at that point right there, which is negative 1.89. And the other little bit of decreasing is right in here. So that is from negative 0.08 to 0.84. So I think it's a good idea when you guys are working on these to draw a nice picture on your paper, get all of these things labeled so that when you have to come up with these increasing and decreasing intervals, it'll be more obvious to you.